Hello students, welcome to the machine learning next class. After understanding the definition of a machine learning or looking into some of the fundamental classes or introduction classes, now let us look into we'll start the actual course of machine learning. Okay, so the main course learning objective here is that you will be able to understand the basic concepts of instance-based learning and decision trees, and we'll be looking into the biasing methods, artificial neural networks, and trying to look into the reinforcement learning. So these are some of the learning course learning objectives, and we have got course outcome also. Okay, so you can just see what all the outcomes at the end of this course you will be able to understand. And we have got a reference textbook and reference book. I think all these books are already provided to you, and prerequisite for this particular machine learning. So for our particular course 18 MCA 53, now the student should know some basic programming skills like at least Python. Now anyhow we will be discussing all those things in later, some algorithmic design techniques and few probabilities and statistics. Now in this course, now we have got 5 modules are there. Now the module 1 covers the introduction and concept of learning and decision trees. Then we will go into artificial neural networks and Bayesian learning, then instance-based learning and reinforcement learning. So this is all the 5 modules. One by one we will be going to cover. So we will start with our module 1. So what are the we have 2 chapters in this module 1. If you look at the outline, in chapter 1, so we will start with the well-posed learning problems. Now here we will take an example of a checker game, and we will try to see that well-posed learning problem, how you are going to do the designing of a learning system. So for that particular example, now how you are going to completely design a learning system, and some of the perspective and issues in machine learning. So this will be trying to cover it in chapter 1. So in second chapter we'll go into the concept learning. So what is a concept learning task, and various one of the very important algorithm called as find yes algorithm. We'll be trying to look that in the second chapter. Now let us start with our module 1. So as you know that, as we have already defined in our introduction classes, what is the definition of machine learning. So ever since the computer started we started using computers. Now always we had one thing in our mind: is it possible for us to make this computer learn on its own? So why every time we need a programmer and everything has to be given a set of instruction in a sequential manner, we call it as a program, and the system has to do that program. Now how it would be better if the program itself learns to improve automatically. That was in every dream what the researchers or the mathematicians were having, but right now the dream has become true because of the artificial intelligence and machine learning. So like say we can say that imagine a computer learning from medical records which treatments are most effective for new diseases. So once you give all the medical records to the computer, the machine itself will start learning. So it can give the results. That means how to treat a particular patient, rather than a doctor is telling. So now can we make the machines to do all those things? Or house learning from experience to optimize energy cost based on a particular pattern of our occupant. Like this, we have so many examples where our machine learning becomes very, very important for us, especially for humankind. So some of the, I think already we have discussed all these things, some of the successful machine learning algorithms in our introduction class, and why machine learning is important. And now this slide also, I think we have covered it in our previous class. So we'll move to this the next slide, areas of machine learning. This also we have studied, covered it well, some of the areas like statistics, brain model, adaptive control theory, psychology, AI, evolutionary models. So these are all the influence areas. So we'll start from here. The technical engineering definition of a machine learning. Again, we are trying to try to understand these three things. So one is the experience E, the task T, and the performance measure P. So a computer program is set to learn from experience E, right? Experience E means various data sets we are going to give for training in order to solve some task, and whenever you are going to keep on solving this task from the experience E, you have to look into your performance measure. Your performance measure should keep on improving. That's what we say. If its performance at task T as measured by P improves with experience. So it is very obvious that every time when you keep on doing the same task with the lot of data sets or training examples or training sets, which you are going to call it as experience, now your performance measure has to increase. This is the engineering or a very specific definition of a machine learning, right? So why you are going to learn? So learning is useful, as you know that human expertise does not exist in many of the places, like say for example in Mars. Now in Mars it's very difficult for human being to go there and try to do a study, right? So here some machine has to do it, or we can say the speech recognition. So humans we are unable to explain more about the speech recognition. How does an animal or how does a human being able to recognize the speech? We don't have such a type of expertise right now what we are having. So we need some machines which can be programmed, which can learn on its own and try to give the solution. That is why this particular machine learning becomes very important. So now let us come to the actual concept. What do you mean by well-posed learning problems? Now that is the same definition, this well-posed learning problem. The definition is, once again, as we have stated, a computer program is said to learn from experience with respect to some class of task and the performance measure, and if its performance at that particular task improves with experience, so with respect to our performance measure P. Now to have a well-defined learning problems, as we said, these three are three important features. So we have seen various examples in our introduction classes how to identify these three things, that is classes of task T, the measure of performance which is to be improved, that is the P, because every time the measure of performance has to improve. It cannot be same or it cannot go back, right? It has to keep on improving. And the source of experience. So how we are able to identify this T, E and P? So we have taken some examples in our previous introduction class and we have seen. So one of the game what we will be designing our learning system in the chapter 1 is this called the checker game. So this is the checker board. Now I have already discussed try to play this checker game online in your Google. If you just type, you can play it online and you can check. It is very easy. You can understand the rules. Now here each pawn, now it is like say we have white color pawn and we have black color pawn. Each pawn is kept on the black square box, and this pawn can move in either only in the black box only. You cannot, like say for example this pawn if you take, now to move this pawn there are only two rules or two moves are there for this pawn. One is either it can move in this particular cell, or we can keep this pawn in this particular cell, right? In only one direction it can go. Okay, so this or say for example if you take this pawn, now either it can move in this direction, but in this place is already occupied by the opponent. So now if it is the turn of white, so then from here now he has to move the pawn to this empty cell only. He cannot come back, right? He cannot come back. So this is what only the one basic rule we are having. So like this, when you keep on moving and once this white pawn occupies this the opponent's last row, then we term it as a king, and now then that king can move in all the 4 directions until that. Now this white pawn can be moved only in this place here. If you take this, it can be moved in this place, or it can be kept in this particular place, no other place. Or if you take this black here, now black can be moved in this place only, you cannot move it here. Already the opponent has occupied this particular thing. So now if there is any gap, so like say for example, now suppose say that here if this pawn is not there, so then black, the opponent, the black player, from here he can jump into this player and he can eat this particular pawn. That means the 1 point is been reduced for this white opponent. So we have some of the rules for the checker game. So like say the as you can see here, checker is played by the 2 players. Now we have 2 players. Each player begins the game with 12 colored discs. So there are 12 colored discs. So one set is black and the other set is red, a red color. It need not be black and red color only, but try to identify that. Now one player 1 plays with one set of 12 color discs, and the player 2 is going to play with another color. So let us understand it's a black and red color disc. Now each player plays his or her piece on the 12 dark square closest to him. So 12 dark square. So as you can see, if all the board position, initially it will be here, right? Let us say that all will be in the 2 rows only. So then you will be having only 2 moves. So in the black moves only. So totally the board consists of 64 squares, and alternative 32 will be dark and 32 will be light colored square. Now it is positioned so that each player has a light square on the right side corner and closest to him or her. So we can either have a left side or the right side, and the player wins the game when the opponent cannot make a move. So this is the winning position. So when an opponent cannot move any move, so then we can say that the particular player A has won if B cannot move any of his pawn. So in most cases all the opponent's piece will be captured. So we say that once we start capturing one piece, so all the opponent's player will be captured, and you are going to block the entire board such that if the opponent is having 1 or 2 pawn, he won't be able to move only. So then we can say that he has lost the game. Now there are certain very simple rules are available for this particular game. So like say for example, the rules are: moves are allowed only in dark square. As I clearly explained in the previous slide, that we can move the pawns only in dark square. Say for example, if white is player 1, he can move this only in dark. He cannot move it in this light color. Similarly, if we consider this black player, now he can move his pawn only in black square, in this dark square only. He cannot move it in white. Okay, don't get confused here whether it is player A or player B. So the pawn what they are going to move, they should move only in dark square only. They cannot move in this light color square. That is one of the rules what we are having. So moves are allowed only in the dark square. So pieces always move diagonally. As I explained, it can move only in diagonal. Single piece are allowed or always limited to forward moves only. So towards your opponent, you can move only in one direction, that is in the forward direction. There is no reverse. You cannot come back, or you cannot move it back. Like say for example, now here as in white player or player A, he can move only in this direction. He can move in the forward. So you cannot keep this pawn here. Even though here place is there, you cannot keep the white pawn here. This white pawn should be kept either in this place or it should be kept in this place. But this place is occupied by opponent, so you cannot keep it here. So you can only keep it in this particular place. So a piece making a non-capturing move may move only. So if you don't have the move, wherever place is there, only there you can move the pawn. Now a piece makes a capturing move. So what you mean by a capturing move or a jump? So we say that you can jump and you can capture your opponent piece. right? Only if space is available. Like say for example, I don't think here we don't have any option here where we can make a move, jump. Let us assume that this pawn, let us assume that this white pawn is not there and it is the play of black color. Okay, now if this player wants to play and assume that this pawn is not there, right? If this pawn is not there, so then the black, it can move in this direction, right? We can move it here in the forward, it is going to come, it can be kept it here, or he can make a jump, he can make a jump from here to here. If this is empty, he can make a jump from here to here and he can eat this, he can capture this white pawn. So if he capture this white pawn, so he gets 1 point, so his point keeps on increasing, right? We call it as a jump. So we can say that a capturing move or a jump you can make over one of the opponent's piece, landing in a straight diagonal line on the other side. Now only one piece may be captured in a single jump. Now this also you have to remember, only one piece you can capture in a single jump, but you can have multiple jumps are allowed during a single turn. So you can have multiple jumps you can have in a single turn, but only one piece can be captured. So when a piece is captured, it is removed from the board. Once you capture a piece, you are going to remove that particular from the board, and if the player is able to make a capture, there is no option, the jump must be made. If you don't have any other option, then you are going to make a jump and you are going to capture that particular piece. Now like this, another important moves is that so once you keep on capturing, and once a player's pawn reaches his opponent board, that is when a piece reaches the forest row from the player who controls that piece, it is grounded and becomes a queen. Like say in this example, now if this side is a black color pawn and this is the white players, suppose say that by keep on moving, if white has reached to the opponent's last layer, so then white is grounded, that pawn, whichever pawn has reached here, now that is grounded as a king. Either it may be this players, or if it is players 2, and if the players 2, that is black pawn, reaches any of this 1 2 3 4, any of this dark square in this row, so then automatically now we call that as a king. So we crown that particular as a king. Now once the pawn becomes a king, now it can move in forward direction as well as a backward direction also. So because now once it is pawned as a king, now he has got more advantages, right? So these are some of the rules. So that's why I told you, just go to the Google, now you just try to play this particular game online. So you will come to know it is a very interesting and very simple game also. Okay, these are some of the rules what we have seen in this particular game. Now let us come back to our well-defined learning problem. So as we said, well-defined learning problem means now those three parameters are important. One is our task, the performance measure, and the experience. You have to identify these things. So as we told, so in this chapter we will be looking into this particular example. It is the checker learning problem. Now what is our task here? We are going to play the checker. So we want to play this particular game, and the performance measure is that the percentage of games won against the opponent. Now how much percentage, or how much is your winning percentage, and the training experience, that is the practice games, how many games you are going to practice. Similarly for handwritten recognition learning problem, we can define what is T, P and E. So in our introduction class we have seen all these examples and we have discussed on this. Okay, now let us come to the actual learning system. So how we are going to design a learning system? So given a particular problem definition, right, problem description, that is a checker learning problem, it can be your handwritten recognition problem or automatic driving problem. So we have discussed so many problems as an examples in our previous video. Now whatever might be your problem, now there are certain steps which is we are saying that in order to design a learning system. So we have basically 5 steps for designing learning system. I can see here the first step is called as the choosing the training experience, right? So you are going to let us go to the, I think, okay, here you can observe it carefully. So designing a learning system, now we have 5 basic steps here. The first step is the choosing the training experience, right? So how you are going to choose the training experience? Now you just take a simple example that now you want to start, you don't know, I think many of us, all of us know how to play the cricket, etc. Assume that you are a small kid and you want to start learning how to play a cricket. So what is the first thing your parents are going to do? The first and the foremost thing is that they first select who is the trainer, right? Somebody has to train you for that particular game, for cricket. So they go and check who is a good trainer who can train my kids how to play the cricket, right? So here also in our learning, designing a learning system also, the first thing what we are supposed to do is you have to choose the training experience, right? So you have to choose the training experience E. What should be our training? So second step is choosing the target function. Now we are supposed to select what is this target function and all. We'll be looking one by one. So you have to select. Second step is choosing the target function. The third one is choosing a representation for the target function. Once you identify what is your target function, now how to represent that particular target function is also very important. So next is approximate algorithm. Now you have to find a function, you have to select a function or design a function or write a function for approximate algorithm. Now there in the fourth step you will be looking into the estimating the training values and adjusting the weights, and the last step is the final design. So these are the 5 important steps in our designing a learning system, right? So again, this is a very important question with respect to the examination. So where you have to write all the, depending upon the marks, you will be explaining all these points. So the basic design issue, okay, so when we are going to look into our learning system, considering this example, so the basic design issue and approach to machine learning is illustrated by considering the designing of learning to play checker. So we are going to consider this particular game and we try to design our entire learning system. Now what is our goal of our learning system is that now you are to design your learning system should be so good that you are going to play world checker tournament, right? Your task is to be at that level, not a simple ordinary. Now you are entering into a world chess tournament, right? So we'll start with first step, choosing the training experience. Now as I said that before you start learning the game cricket, now you are going to select, okay, who is the good coach for us. You have to select a coach because the coach is the person who is going to train you. Without a coach you cannot start learning that particular game, right? Now here the first step is choosing the training experience. Now the first design choice is to choose the type of training experience from which the system is going to learn. So now your system starts learning from this training experience. So you have to catch the coach. You have to go in search of a coach, right? Who is a good coach? Because from coach now you are going to learn the cricket. Similarly here, now the system will be learning from where the system starts learning from this training experience. The type of training experience available can have a significant impact on success or failure of the learner. So this is very important, right? The type of the training experience. Now what type of training experience you are providing, what type of a coach you are hiring, right? If you are having a good coach, so then obviously the failure or the success of that particular person, it depends upon the coach, That is why you see that in lot of games you see that why the coaches are heavily paid huge amount, because the coach is a person from whom you are learning. So how you are learning, the success rate of that particular player, whether it is going to failure or success, it entirely depends upon the coach and his ideas. Because and his experience, from this experience only the player is going to learn. Now here also your machine learning system, it can be either success or the failure, or you can even think in another perspective that now we had one parameter in our definition of machine learning called the performance measure P. Now if your performance measure P wants to increase, right, so the success rate you want to increase, always you are going to increase your success rate, you don't want your failure rate to increase, right? Nobody is going to identify this. Your failure rate should be less, whereas success rate should be more. So for your success rate to be more, so the type of training experience available, it is very, very important. Now to select this training experience, now there are three attributes which impact on success or failure of our learner, right? Now whether the what is the percentage of your success or the failure, now it depends upon three important parameters. Now let us see what are these three important parameters. The first one is whether the training experience provides direct or indirect feedback regarding the choice made by the performance system. Now there is a performance system. Now whether the training experience provides direct or indirect feedback. Now there are two types of feedback, right? Now one is called as a direct and the other one is called as the indirect feedback. Now what type of feedback it is trying to provide, whether it is a direct or indirect feedback. Based on this direct or indirect feedback, the performance system is going to make a choice. Say for example, now you have got one performance system. You have two ways of playing a game. Okay, let us say we have two choices of playing a game. Now the performance system has to select either the first, in another simple term, let us say that assume that your performance system is a person with the captain. The umpire is going to toss a coin and you are going to decide whether you are going to bat first or take the bowling, right? The toss becomes very important here. So now when the toss is important, now it depends upon the captain. Now how he is going to take, which one he is going to select when the option is given for you, right? So an option is given for you, when choice is given for you, either you have to select batting first or you are going to select bowling first. That to many extent it has got the direct impact on success or failure rate. I think you got this point clear. So what we are telling, the first attribute is that whether the training experience, it provides a direct or indirect feedback regarding the choices made. The second important attribute is the degree to which the learner controls the sequence of training example. Now what is the degree? What is to what level the learner controls the sequence of training examples? Now when you have got n number of training examples, in what sequence, to what level of degree the learner is going to control, that's another important attribute. And the third attribute is how well it represents the distribution of examples over which the final systems or the performance must be measured. Now when you are going to measure your final performance, when you are going to look our final system result, now what is the representation, that is the distributions, what type of examples over which distributions which the final performance must be measured. Like here we said that okay, your checker game, you are looking for world chess champion, right? So that means to that level you should have some measure, or we can say the representation of our distribution of examples. So these are the three important attributes on which our we can say that the selecting the training experience depends. right? So these are the three important parameters. Now we will be looking one by one of these attributes more detail with respect to our checker game. So what is the first parameter, what is the first important point we discussed? Whether the training experience provides direct or indirect feedback regarding the choice made by the performance system. So let us take the example of this checker game. Now in learning to play checker, the system might learn from direct training examples. Now what is this direct training example? Now when you want to design your particular system, now when you are giving a training examples, so direct training examples means there will be lot of individual checker board states. Okay, like say for example you want to train chess. Just like a checker, you have got a chess. Now if you want to give a direct training example means you will take a board configuration, right? Let us say Vishwanathan Anand, when he has won one particular grandmaster or one championship. Now in that particular championship, in his entire game, what was all the different moves he made, the board configuration you are going to collect, right? Like this. So the direct training example, it consists of individual checkerboard states. After one move, what was the board position? Once a player A is going to make a move, then what is the board position? Next player B is going to make a move, what is the board position? Like this, you are going to collect individual board status, right? You are going to collect all this board status and the correct move for each, right? So once, like say first time player A makes one move, then you take the board state. Now after that, what is the correct move available for him? Or say once player A makes a move, so now player B is the second next turn is player B. Now at that moment of time, you capture the board state and you are going to see what is the correct move for each, right? So you have all the board states and what all the correct moves are available. So this we call it as the direct training example, right? That is direct feedback mechanism. So we have two here, one is direct and indirect feedback. Now indirect training example, now what do you mean by indirect training example? Now indirect training example consists of move sequence and final outcome of various played game. Now here what happens in indirect training, now you just provide all the move sequences. You are just providing the move sequences and what is the final output. So what is the final output, whether player A has won or player A has lost, right? Suppose for one particular player. So you just collect all the move sequences, right? You in the entire game, let us say in the checker game, so the two persons are playing, player A and player B. Now if you are player A, now you want to see that player A, or you have won the move or you have won the game or you have lost the game. That is the final outcome. Let us assume that you have won the game. So the final outcome is you have won the game. To win that particular game, what are the move sequences you have done? You might have won the game in 10 moves, or you might have won the game in 15 moves or 20 moves. You just collect the move sequences. We call that as indirect training examples. I think right now you might be clear what is the difference between direct and indirect feedback. In direct feedback, now the board states and the correct move is given for after every move. What was your board state and what was the correct move? What possibilities are there? It is just like saying the coach is telling after this move you go this, you do this, right? You have which is the correct move once you are in that particular position. That we call it as a direct. Whereas indirect, nothing is told for you, just total move sequence is given and you will be having the final outcome. So this is what we say that direct and indirect feedback system, which is available for our training for selecting the trainer, right? So the information about the correctness of a specific move, which move is correct, the correctness of a specific move early in the game must be inferred indirectly from the fact that the game was eventually won or lost. So this is also very important. So which move, the specific moves, when you have got so many moves, the information about the correctness of a specific move, so it should be well known, or it has to be learned in the early stage itself, and you are supposed to infer that indirectly. So indirectly, with your learning experience, you are going to infer that from the fact that the games was eventually won or lost. So here the learner faces an additional problem. So when we look into the direct and indirect move, now here we can say that learning from direct training feedback is easier. So because when you look into the direct training, now everything is given for us. Available board states are given. From that state, which is the correct move, that also you will be knowing in which move if you go, you might be winning. So when you go for indirect feedback, now those things are not given. Just a simple, all these move sequences are given. Which sequence to apply when it is not known to you, that you have to infer. That's what it is telling. So you are given collectively, you are given around 20 moves, and it is said that in this 20 moves you are going to win the game. But which move to be applied when, at which particular board position you are going to apply which move, that is not told. That you have to infer it. So you have to infer it from your learning process. So at that particular board position, the correctness of specific move. So which move will be correct for me, such that you are going to win that particular move. So that has to be inferred indirectly. Right now, this becomes more difficult for us, whereas the direct feedback is very easy. The reason why it is very easy, because you know the move sequences, you know at which board state which move has to be applied. So we see that when we are going for indirect feedback, so then it is little bit difficult. So here the learner faces an additional problem of credit assessment, right? So our credit assessment, that's what it's very important when we are going for indirect feedback. That is determining the degree to which each move in the sequence is deserve credit or blame for the final outcome. Because now you just have some list of move sequences. Now you are going to select. So that how you are going to select that? Okay, if I select this move, anyhow all the move sequences what is available with you, it might be going to end up with a winning the game. But at that particular point, if you are going to the credibility, determine the degree to which each move in the sequence. So either it can be a credit, that means it can be a positive for you, or it might be blame. It might lose, means your points will be reduced, so that there is a chance that you might lose the game. So credit assignment, it can be particularly, this credit assignment is a difficult problem, because the game can be lost even when early moves are optional. So even you can lose the game if your moves are not selected, if you are not applying your moves properly in optionally manner. So at the initial step itself, if you are making a very poor moves, then even though you might be in a winning position, but you will be eventually losing that particular game because of the way you have selected the move. That is, the credit assignment becomes very, very important. So that's why, so we say that now when you are going, when you are looking into your training experience, so the direct or indirect feedback made by your performance system, so that is one of the important attributes. So now what we have seen here, 3 attributes which makes you your system to either success or failure. One is your performance measure, how the performance measure or a performance system is going to make a move, either by direct feedback or indirect feedback. So this is the first important attribute. The second important attribute is our degree to which the learning, the degree to which the learner controls the sequence of our training example, right? So now the second important, the second and third, these other things we'll be discussing it in our next class. So if you have got any doubts, especially here, that is choosing the training experience, you can just put a all your queries in classroom or in WhatsApp. Okay, thank you. So in the next class we will go further and we'll try to look into the other important aspects. Now before we go into the other things, so once you have downloaded this particular class or videos, try to play the checker game online. So I request everybody, so before you start looking into the next video or in the next class, I want everybody to know what are the rules, how to play the checker game. Try to play it online. In just Google, you just type checker play online. You have so many websites you are going to get. You just try to play and you see what are the rules and how you are going to play. Okay, so before we come to the next class, I hope that everybody know how to play this particular game. Thank you. So we'll wind up our class here. Okay.